Hello everybody and welcome back. So in this next lesson we're going to be tackling arrays. Now as I've said before, this is something that I find a lot of beginners have a little bit of a problem with grappling with, getting their head wrapped around exactly what an array is or how to work with it. But once you know how to do it, it's actually not that hard and it's very, very powerful. Plus you're going to use it all throughout your coding. So best to learn it now, not let it become a thing that you avoid for a while. Just dive straight in. I'm going to explain it all. If you don't understand anything here, just keep coming back to this section until you do. But we are going to use this quite a lot later on when we're building the final tools. So it will make more sense by the end. And certainly if it's ever not, just come back, repeat this lesson, or ask me on the forums, and we'll make sure we get everyone understanding arrays and what they can do, because they are incredibly powerful tools. Okay, so what we're going to do is I'm going to talk about all the different types of arrays that we have in Python, and as I go through each one, we're going to discuss their pros and cons, and we're going to go through a list of functions that you can use to work with these arrays. Both, altering them, adding new values, taking values away, copying them, whatever you need to do in order to kind of manipulate these. Now, really, at the end of the day, an array is just multiple values stored in one variable, or, stored as a single value or single object, as Python would call it. So think of it, even though we're going to get much more complicated here, just think of it in terms of like your color for your particles. If you have points in your Houdini scene and they have a color, that color is not a single value. It's a RGB value, so red, green, and blue. It has to store these three values together in order to represent color. Now, in Houdini, color is actually stored, it is stored as a vector attribute, so it is called as with one attribute name, so that's CD, but in your geometry spreadsheet it does display it as three separate channels of one attribute. So it kind of toes that line between being a true array and actually just being three separate single values that are just somehow linked with a common name. So, but they are essentially arrays, same as point position, or if you have your quaternions, that's a four float array, so it's a four float vector, which is basically an array. All right, so these are all examples of where you're going to come across arrays in general, but we're going to start going through these, and you'll see how we can do a lot more than just storing XYZ or RGB or even RGBA or maybe a matrix or whatever. Here we can store a wide variety of things, and then we can loop through these lists, and that's what makes them so powerful. Okay, so this is going to be quite a big topic, so let's get started. Now, there's the first two that we're going to tackle are relatively similar to one another. And I have mentioned these all before, so they should be at least familiar enough to you to be able to recognize them. And that is tuples and lists. So let's start with tuples because they are the most basic form of array because there's not a lot you can do with them. So for an example, I'm going to create a variable called myTuple, and I'm going to store an actual tuple in here, and then we're going to work with this. So tuples are defined by round brackets. So both when they're printed and when you create them, you use round brackets. Okay, so let's go and store a bunch of values in here. So we'll store 2, 4. I'm also going to make sure that I give it a float. So let's say 5.7, and I'll give it a string. So I'll type something. Okay, because I want to show you that you can use multiple different data types within one list in Python, which is quite cool. So once we've created that, if I just print my tuple, it's going to print that list. Now, it did happen to actually type these numbers in order, but if I hadn't, if I had typed the 4 over here in the first index, it would not have reordered it in alphanumeric order. The order that you place these over here is the order that they will stay in. So it doesn't matter if 2 is over here and then after something I put comma 1, that 1 will stay at the end. It does not reorder itself, okay? So what that means is that a tuple is an ordered list. In other words, the order matters, and the order is actually stored with those values. So basically this value is stored in the first index, and this value is stored in the second index. It's not just a random list that can kind of just be shuffled around. They slot into one specific index in this array, okay? So, and just for anyone who's super new to it, when I talk about an index, that is the number of the item inside of this list. So here we have 4 items, 4 indices, and indices are always 0 based, which means the first index is index 0, not 1, okay? Then the second index is 1, the third would be 2, and so on, okay? So just in case somebody is very new and they've never heard of an index. Okay, so tuples are ordered, but they are also immutable. Now this means that they cannot be changed. So that's why this is so simple to work with tuples, is we can't just take my tuple and just add something to it or remove an item from it. So, you know, what we would normally be able to do with a list is maybe append 1 to the end of this list. Well, a tuple says basically, no, you can't do that, right? Sorry, print my tuple. You see, it has not added the 1 at the end here. It errored out saying, I can't add to this. A tuple is set, it is static, okay? And another cool aspect of tuples is that duplicate values are possible. So let me actually go back to where I set my tuple over here, and just to show you the order thing, I'm going to actually go and add in a 1 over here, and I'm also going to add another 2 because we already have a 2. Okay. Now note here, I'm just overwriting my original array, so I'm not adding it, I'm adding to it, I'm not deleting from it, I'm just simply overriding this variable. That is the only way that you can alter a tuple, is basically to just create a new one over the same variable. Okay, so here we are. If I print my tuple, you're going to see that the 1 is still over here where we put it, and the 2 does exist, so we are allowed duplicates. Okay, now there are a small range of functions that can work with tuples, because obviously without being able to change them, there's not that much we can do to it. Okay, so the first thing we're going to talk about is getting data out of a tuple. So when we're working with a tuple, so here's the variable. Now obviously if I print the entire variable, I get the entire list, which is great, but how do I actually work with this? What if I want to grab single values from this list? Okay, so we use square brackets when working with arrays to access data within the array. So if I hit square brackets here, and it's just immediately after the name of the variable, you just put a square bracket and then you give it the index that you want to return. So if I say 2, what that's saying is go and return the second, well actually technically the third index of this list, because remember it starts from 0. So it'll be 0, 1, 2. So it should give me 5.7. See there? Okay. Now, indices count, so for example, 0 will return the first one, so they count upwards. However, you can also use negative values, and if you use a negative value, what it does is it grabs from the end of the array counting backwards. Okay, but this is not 0 based. I know this can be a little bit confusing, but -1 will be the first index backwards from the end of the array. Okay, because you can think of 0 as being here, and then -1 is going to go backwards, so it loops back to here. So this is -1. Okay, it couldn't be -0 because there is no such thing. 0 is 0. There is no such thing as a -0, and so 0 is this, which means that -1 has to be at the end here, and -2 would be this one. Okay, so if we say -1, it'll return 2. If we say -2, well, let's say -3, so then it should return the word something, okay? Because here it's gone -1, -2, and then -3, and it returns that item. Okay, so that's how we can just grab a single item from an array. Now, you can also, with tuples, you can use the index function. And you're also going to see here in the Python shell, when we hit dot, it's going to show you the list of functions that are available for this data type. And as I said, there's very few. Normally there's a much longer list than just 2. But we're going to talk about this index function. Now, basically, this is going to return the first index that it finds with a particular given value. Okay, so this is the reverse of saying, give me index number 2, and then it gives you the value. Instead, we give it a value and say, search in this array for that value and tell me where it is within the array. In other words, what is the index? So I say now 4, okay, so index 4, and it returns 1. So what does that mean? So when I gave it 4 here, what it did is it searched this array, and it searches it in order, finds the number 4 here, which is equal to this, okay, so it does an equivalency check, and then says, okay, where is this? What index is it stored in? Well, this is 0, this is 1, so it returns 1, telling me which index the number 4 is within, okay. Now, what if I do this with 2? Because we have 2 2s, so when I hit enter here, it's going to return 0. The reason for this is it starts from the beginning and it finds the first one and then it just stops. Does not search the rest of the array, okay? So it will only bring the first one that it finds of that value. Okay. So now, something else we may want to do with tuples, since we can't alter them, there's not that much we can do, but we can check them. So check them for information, right? So one thing we can do is check whether a certain value exists within this array, right? And that's using our in keyword, okay? So if I say, let's do our 5.7, okay? So let's use our 5.7, and we want to check whether 5.7 is in my tuple, okay? And that will now return a true. If I say 5.0 in my tuple, it will say false, right? So basically, it's checking the list and saying, is this an item within that list? Okay. If 5.7 is in my tuple, then it will say yes, true, found it. Okay. So it's just a simple way to check whether a value exists within a tuple. And then we can also use the count, which is the other of the very long list of functions that we have available to us. Okay, so count is going to return the number of occurrences of a value, right? You'll see here when we open brackets, it actually explains to us what this function is going to do, and so it's quite useful. So if we say, let's use our 5.7 again, right? Then it's going to say 1. Now that's not saying that it's at index number 1. It's saying that there is one instance of 5.7 in this list. So if we went and said 2, it's now going to return 2 because it has found 2 2s in the list. Okay. Right. Now other than that, there's not much else to say about tuples. You cannot change them, there's no functions to add to them, remove items, or any other functions, okay? The list is very short. Mostly, tuples are going to be spit out by other functions. And if we create a function where we want to return some value, unless that is an internal function that is used only by our own code, then generally we're going to want to return a tuple instead of a list. The reason being is you don't want people to get a value out of your function and then alter it and without kind of fully understanding what they're doing. In order to, you kind of want to force them to take the value that you give them and create a copy of it to work with it, because otherwise things can just kind of get muddied up. And so you kind of want to return something to them in a way where it can't be altered. It's kind of like if you buy a product from a store, you know, you buy a new television. It's got that like sticker over the back where the screws are. So it's sort of like if you break this sticker or remove the sticker to unscrew it and open the product up, then, well, you've voided the warranty, and it's kind of like, well, it's up to you now if the TV works or not, because we're not going to fix it. I sort of like to think of tuples that way. We're packaging it in a way that we're saying, I'm going to give you these values. You now, if you want to change them or do something to them, that's on you. Okay, so that's tuples. Now, lists are very similar. Okay, so you're going to see a lot of similarities between lists and tuples, but you can basically think of lists as exactly the same thing, except we can change the values. But that now gives us a lot more functions that we can run in order to change these values. So let's create a list. So I'll say my list equals, and now in this case we're going to use square brackets. So let's feed it a whole bunch of values. So let's give it the word foo. By the way, for anyone who doesn't know, the word foo comes up a lot when you're coding. Basically, it's just like a nothing, null, empty word that people always use when they sort of can't think of a variable. Generally, you'll see like someone will test something with a variable. They'll say foo equals whatever. Like they'll store a test value in foo. The reason we don't use the word test is because you can legitimately be testing for something, and some functions might even have a sub function called test. So test is a little bit of a word that is a bit ambiguous. It's used by other things, whereas whenever you see the word foo, it basically means this value is being used as a test. It will never be called later on by another function and sort of informs an intrinsic part of the actual code. It is just a random little, test. Okay. So yeah, just if you ever see foo, just know that it should not be part of the code. And if you ever use foo, please just use it as testing. You can store a variable and then like print foo just to check what's happening. But you never go and store a value in foo and then later on use it, and it ends up being part of our actual final packaged code. That is very bad practice, so please don't do that. Okay, so in my list, I'm going to put foo, and then let's give it some values. So 6, and then 8.4, and then I'm actually going to give it a few values that are in common with this tuple. You'll see why later. So I'm going to say 5.7. And I'm also going to give it 3 1s. Okay, that should be enough, right? So we've got a few floats and integers and a string. Okay, so when I print my list, you'll see it stays in exactly the same order, exactly the same as a tuple, right? So it is an ordered list. The indices matter. It is not immutable, right? So it is editable. And so that's the only difference between lists and tuples. And the same as tuples, duplicate membership is allowed. So you can have multiple ones or multiple of whatever item. It doesn't matter. In fact, you could have a list of 1,000 of the exact same value. Okay. Right. So let's talk about the functions now that we can apply to these lists. So let's talk first about getting data out. So my list, and exactly the same as with a tuple, we can just feed it an index and it will spit out that value. So 0, 1, 2, 3, 4, that's that one, and it's returned exactly that. It has returned 1. If I go index 2, it's going to return 8.4 because it's 0, 1, 2. Okay. And same thing, you can use your negatives as well. So -3 is then going to be 1 because it's -1, -2, -3. Okay. Then we can also, exactly the same as tuples, you can use your index. So index function saying, okay, tell me what index the value 8.4 is sitting at. So it says that's at 2, 0, 1, 2, exactly right. Okay. Now we can check our data in our list as well, which is exactly the same as with a tuple. So we say, does 5.8 exist in my list? And it will say true. Does the word something exist in my list? False, because it does not. Okay. And exactly the same as a tuple, we also have the count function. So mylist.count, and we say, tell me how many ones there are. There are 3 ones. Tell me how many foods there are. There's only 1. Okay. So that's all the same as tuples, but now we get to the point where it's a little bit different. So let's change a value. Okay. So in the same way that we can call a certain index, okay, so we can say mylist2 and it spits out 8.4. Well, if we just now set, so we use an equal sign to set the value, what we're doing is saying override index number 2 with this new value that I'm going to give you. And let's give it, I don't know, 3.86. Okay. So now when I type mylist and print it, there is our new value stored in that area. So you'll see this one edits it in place. So it doesn't just return or print the new value. Here we're taking that value and storing it inside that index. So it actually does alter the list itself. Okay. So that's how we can change a value. And exactly the same, you can use your negatives as well. So you can say -1, change that value to be equal to maybe 1.0. So it's a 1, but it's actually a float. Okay. So you'll see there, we've now changed that one to 1.0. Okay. Now, adding. So let's talk about how we can actually add items to a list. Right? So if we have this list and we say what we want to do is increase the number of items in our list, right? So not just the ones that we have printed over here or altering any that are already still there, but we want to actually increase this, right? The first item, or the first function we're going to talk about is append, okay? So append just means add an item, and it adds it to the end of this list, okay, which is actually what the word append means. Okay, so if we insert, let's say, I don't know, let's maybe do something else. So I'll type the word else, okay, for something else. So if I print now my list, it's added it at the end there. Okay, so it will always add it at the end. Now if we don't want it to add it at the end, but rather we want to actually insert it somewhere in this list and therefore shift up everything else, everything after it will now get a, its index number will increase. We can insert. Okay, as I've said before, Python's a very intuitive language, and literally the word append means add to the end, and then insert, obviously, well, we want to insert a value somewhere in the middle. I mean, these are very, very intuitive, which is quite cool, because then as you're going through, you look at your code, well, you look at the possible functions, and you kind of can guess what these things do, right? So we're going to insert, and it inserts it before an index, so that's important to know. So if we point to this index, it's going to insert it here, not here. Okay, so in other words, the item that we add will now have the index number that we give it, because obviously it inserts it before and then shifts everything up. So this one will now have an increased index number, and the one that we insert will have this one's number. So 0, 1, 2, 3, 4. Okay, so let's insert it at index number 4. Now the index number comes first. If we go back here, you'll see that it wants the index number, and then it wants the object that we are going to add. Okay, so 4 is the index number, and then here I'm going to just add the let's actually add the word for just for fun. Okay, so let's say my list, and you'll see there that's now in index number 4, and then the rest have been shifted up. Proof of that is if we say my list 4, then that's going to return 4. Okay, and then if we want to add 2 lists together, then we can use the plus. Okay, so let's just say my list 2, right, is equal to, and I'm just going to add a few items here, so I'm just going to use this as an example. So 4, 7, and I don't know, 8.2. Okay, So there's another list. So we've got my list and we've got my list 2, 2 different variables. And then don't forget we still have our tuple, right? My tuple. Okay. Now if I say my list plus my list 2, right, it's going to add them together. It will not alter it in place though, so my list is still left untouched, as is my list 2, but it just prints the new one. So we would have to store that in a new variable. So something like x equals my list plus my list 2. Okay, so you can do that, right? Then we go, let's try my list plus my tuple. Okay, this is where it's going to error, saying you can't concatenate a list and a tuple. Okay, so we have to do this with a different method. Now, if we just append a list to another list, so if we just say my list dot append tuple, my tuple, okay, then what's going to happen is it will succeed, but you see here we will have a nested list. In other words, it has literally added that entire list as one item in this list. Okay, not each item in this iterable has been added to this. Instead, it has one index, which is that. So now if I say my list -1, which is going to return the last item in my list, it will literally return that entire tuple. Now this is a good example to show you that you can have nested arrays, and in fact mixed arrays of different types nested within one another. So a tuple inside a list. You could have a dictionary inside of a tuple, inside of a list, inside of a set if you wanted. Okay, so this is fine if this is what we're actually wanting, but what we wanted to do was actually do something similar to this, where we actually add the items in. Okay, so first of all, I'm just going to remove this last item from the list. Okay, I'll show you how to do that just now, and I'll talk about all the other ways we can do it, but let's just go back to my list being like this. Okay, now if we say my list dot extend, what extend does is it allows us to feed it an iterable. Okay, so in other words, another array that can then be iterated over or looped over and extracted. So each item is extracted from that iterable and added in to this list. So this extend is basically saying append, but append a list or append an iterable. Okay, so if we now feed it my tuple and then I go my list, you'll see here that it has now added those items, but instead of in round brackets as a single item, it has added each of them. Okay, so now let's move on to removing items. So we had to do that just now. So you saw me go my list, and then if I point to a particular index, so if I say maybe -2, which will go with, it'll point to this 1 over here, right? -1, -2. Now, so that's there. Okay, if you use the word, if you use the word del, okay, so delete, and then you point to an index like that, then it will remove that from the list, and it actually does edit in place, so it alters the original list. Okay, so that's one way of deleting a particular item in a list. Another way is with the remove function. So if I say my list dot remove, what this does is it lets me give it a value, and it is going to remove the first occurrence of that value from the list. Okay, and then we'll raise a value error if the value is not present. All right, so we will talk about it, errors later on, much later on, when we do try except blocks. But for now, we're just going to basically, if it errors, then we've gone wrong. Okay, so if I say, for example, 1, that's going to go through in order, like like before, where it's checking for this item in the list and returning the index, right, in our index function. It's going to go through and then when it finds a 1, it's going to remove it and then stop. So this one will be fine, this one will be fine, this one will be removed. Okay, so now when I print my list, you'll see there that we're 1 short. Okay. Right, now I'm actually going to, just for the sake of later on, because I want to show you what happens when we've got so many duplicates in a list, I'm actually going to add this 1 back in. So I'm just going to, well, let's append it, okay? So I can say append and 1, right? Just so that we have my list and we've got another 1 at the end, right? So we can remove things by value or by index. And then we can also do a very old school and traditional kind of way of removing items, which is pop. Okay. Now what a pop does is it removes, almost like the opposite of append, it removes the last item from the list. Okay. And something else that it does though is it returns the value of that. So how del, you see here when I deleted this index, it didn't print anything. Didn't return anything, it just altered the list. Well, pop removes that item, but it also prints or returns the value of that item. Okay, so now if I say my list pop, see there, it prints 1, and when I print my list, it is now missing that 1. So if we wanted to loop through this list and then extract just that last value and kind of work our way backwards through this list, storing our values, we could then say x equals my list dot pop. Okay, now x will equal 2, and my list is missing that 2. Okay, and we can always add it back in, my list dot append x. Okay, so there's a lot of things we will be doing like this inside of loops, right? So that's all the removing of items from lists, and there's only a few more things I want to talk about with lists, and then we're going to actually call it there for this lesson, because arrays, there's so much to talk about, so I'm actually going to move to another lesson just so this is a little bit more manageable, and we'll talk about sets and dictionaries in the next lesson. Okay, so something I want to talk about with these lists, my list, is sorting. So the order is determined by how we've added items, appended them to the end, added lists together, or just the way we created our initial list. But if we want to reorder this list, we can, okay? And that's using the sort function. Now, the sort function takes a few arguments, okay? So it takes this CMP argument, it takes a key argument, and it takes a reverse argument. 3 arguments, but I want to point out something now, which if you've never done coding, you may not know. When a function lists all the arguments at once, if there is an equals sign and a value, what this is saying is that this argument has a default value, okay? Which basically means that if you don't give it that argument, it is going to assume that you meant this value, okay? That means that if I want to now, I don't have to feed it all 3 values, I can just feed it a key. But by doing so, in order to specifically give it this value and not this value, because how does it know if I feed it, let's say, a sorter function over here for the key, how does it know that I don't mean to feed that into the CMP function? Okay, so you have to use a keyword. So you have to use this actual word. So these are called keywords. Okay, so CMP is a keyword, key is a keyword, and then reverse is another keyword. Okay, so if I want to feed it a key, I have to say key equals, and then feed it the key. And then I don't have to feed it CMP, it will just assume that CMP is equal to none, because that is its default value. Okay, so let's move on. Now, that is exactly what we're going to do, by the way, because CMP, I'm not even going to go into and explain. It's an old school method. It's basically redundant now. You don't need to use this. I'm sure there are outside cases if you do much more complex coding, but I have never needed to use this in my experience, and so I'd rather not teach you something that I believe you can work without. Okay. Whereas key, I've used a lot, and reverse. So I'm going to show you how I've come across working with these. Okay, so now without feeding it any functions though, if we just say sort mylist.sort and then I print mylist, you'll see that it has sorted it alphanumerically. Okay, so 1, 1.0, 2, 2, 3.8, and so on. Okay, so it's put all the numbers in order, and then it goes to letters, so it puts your strings at the end, and it has sorted them alphabetically as well. Okay, so that's great. And then there is also, remember, the reverse function. So maybe we want that the other way. We would just set reverse equals true. Okay, and now when we say mylist, then it's reversed. Okay, something else we can do here is if we say 1, I just wanted to show, because I mentioned this before, that 1 can be substituted in place of the word true, and in this case this is a really good example to show you that. So you'll see it does return the reversed order, whereas if we say sort reverse equals 0, then my list will equal this, because it says don't reverse the order, sort it in order. Okay. Now I'm going to show you something here with a sorter function, in case you've ever wanted to use this. This does get a little bit more complicated than what we have done before. So for those who are very, very new to it, this section may make a little bit less sense to you. It won't be very long, but just just kind of hold tight. Okay. Or try to see what I'm doing here, try to understand, but in future lessons it will make a little bit more sense if you've never done anything like this before. Okay, this is more for the people who have done some coding before but maybe just need to brush up on their Python. So I'm going to actually use the Python source editor here, because we are going to type multiple lines. So let me just create a new list. So I'm just going to say my list equals let's make sure we give it a totally different name, even though here these won't have access to this list, but I'm just going to call it my list 3 just for you guys, so you don't get confused. And I'll give it something like, let's just go 4, 7.8, and then whatever. Okay. All right. Now, if we just return, so we just say my list 3 dot sort, and then we print this. Okay, it's going to, I should point out, this is a little mistake of mine. When you run the sort function, it sorts in place. So in other words, it sorts and overwrites the list. It does not return a value. So when we print this, it does nothing. Okay, what we do is we sort it, then we print my list 3. Okay, that will print something. Okay, and it has printed it in order. In fact, actually, that's obviously a bit silly because we've typed it in order, but let's maybe do it this way around. Okay, so there we go. And now when I print it, because I have applied the sort function, it prints it in order. Right. Okay, so here's our little setup. But what we want to do now is we want to feed it an actual sorter function. Because what if we want to sort by something that is not just alphanumeric? Okay, what if we want to do some other function to each of these items as we loop over them to figure out how they should be sorted? For example, what if I wanted to sort these not alphanumerically but by the length of the item itself? For example, 4 has only 1 character, but 7.8 is 3 characters, and then whatever is far more characters, right? So we can create a function called a sorter function that we can feed it as a key, and it will apply that function to each key, like each item as it loops over them, and then use the result of that function to sort the items. Okay, so we're going to create a function here, a sorter function. So I'm even going to call it sorter. Now, this is why I said this gets a little bit more advanced. Later, I am going to teach you guys how to create your own custom functions. So I will go over this in more detail later if it doesn't make sense, but just you can follow along for now. Okay, so We're going to be defining a new function called sorter with the one argument, which is the value, okay? Because the key function is going to feed one argument, so we're going to give it one argument, which is value, okay? And then what we need to do is we need to return the value that it's going to sort by. So we're going to take our value, but in order to check the length of it, really what I want to do is convert it to a string, okay? Because right now, if I want to assess the length of this, I need this to be a string so that 7 is a character, the dot is actually a character on its own, and 8 is a character on its own, okay? So I'm going to use our str to convert our value to a string, and then I'm going to use the len function, which reads the length of a string, okay? So for example, for the word whatever, it's going to read 8 characters from this. So it's going to len of whatever would return 8, okay? So here it's going to return 3, here it's going to return 1, and this is going to return 8. It's going to put those three numbers, 1, 3, and 8, alphanumerically, and then it will sort these actual values by that same index reordering. Okay, and all I have to do here in sort is feed it this function as in the key. But note that we don't run the function, we don't put the brackets, we just feed it the function as an object, because remember, our functions are objects as well. This is a data type, okay? This is an actual object, and we are feeding this object in as the key function. And now when I hit apply, right, it's going to sort it for 7.8 and whatever. Okay, now I know that's the same as this. Let's actually swap this around. So let's say 0.87. Okay, so now this will actually be longer than 7.8. So 7.8 should come first, right? So you'll see there that now, this time around, it's put 7.8 first because it has 3 characters, and then 4.87 is 4, and then this is 8. Okay, and if I had to put a whole bunch more numbers over here and then print it, then that will come at the end because it has more characters than whatever, right? But if we take away this key, then it's going to sort it alphanumerically, which 4.87, doesn't matter how many points I add after this, it's still going to be smaller than 7.8 and then whatever, because it's sorting alphanumerically by the first character. Okay. So that's just diving a little bit more advanced, but this is really, really useful. Sometimes you really need it. So as I said before, this whole section in the beginning where I'm talking about all of these things, it can be a handy reference for later. So even if there's certain things you're not quite following now, feel free, just ignore it for now. But later on, when you come across sorter functions, you now have this lesson to be able to go back to and get a handy explanation of how it works. Okay. So one other thing I just want to show you is reverse, and that is just if we print my list again. So this is my whole list. Okay, if I just type my list dot reverse, it's just going to reverse the list as is. Now we happen to already have sorted this alphanumerically, but it doesn't matter if we have or haven't. We can do it to, like, let's say my list 2, okay, or whatever. It doesn't really matter. All it's going to do is reverse the order. It's not going to sort it in any way. It's only going to reverse what it was. Okay. Okay. So that about does it for lists and tuples. Oh yeah, hang on. Let me actually show you this. There are a few things that we can do between both lists and tuples. So let's cover those, and then I'm going to call it a day for this lesson, and we'll move on to the next one soon. Right. So slicing. This is something very, very useful. Now we sort of have done this already. If I call my list, and then let's call index 4. Okay. So 0, 1, 2, 3, 4. There we are. Now, if instead of grabbing a single item, what I want to do is slice a section of this array. So instead of giving one index number, I can just use a colon to tell it to grab a range of indices. But then obviously because I'm referring to a range, it's multiple numbers, so that's going to return another array instead of a single value. Okay. Now the colon is basically saying go from this to this. Okay, don't worry about this word. I'm just using this as a placeholder. Okay, so in other words, start to end is what it's going to return. Okay, so for example, if we tell it for colon and then 6, that means it's going to go from the 4th index to the 6th index and return those numbers. Okay, now it actually goes one back from the 6, so behind this index is where it creates the end of the slice. So this is 0, 1, 2, 3, 4. It starts from before 4, so the slice starts here where my cursor is. It selects everything from that point. Now this is index 5 and this is index 6. So before index 6, it creates the end of the slice. And so it slices from here to here and returns that, which is 3.86 and 4 as a list. Okay. Same thing if we went and changed this 6 to an 8, it'll now give us a bigger chunk of this. So it selects from here to there. Okay. Because that's 4, 5, 6, 7. And then this is index 8. So that's where it creates the slice. Okay. Now one thing you can do is leave out numbers in this slice. If I say just leave out this, so nothing, colon 8, what that does is selects from the beginning of the list up until index 8. Okay, so now it starts right from the beginning and goes up until index 8 and then creates the slice right before that. Okay, and you can also do it the other way around. So you can say 4 colon, and then that's saying from 4 onwards right to the end. Okay, and it doesn't matter how long our array is, it's just going to select from 4 onwards. Right. Okay. Now, we can also do that with just colon, and that means that it's going to return the entire list because it's going to go from the beginning to the end of the list. And that seems a little bit redundant, but we are going to use that, and I'm going to show you why right now. Okay. So, before we show you that and the use for that, let's talk about copying lists, right? So if I say that, so I've got a list which is called my list, but now what if I say x equals my list? Okay. Now when I print x, it prints this, and when I print my list, it prints that. Okay. Exact same thing, right? But let's use what we learned in the last lesson, right? Let's check our IDs for this. So if I say ID X and ID my list, these both have the same ID, the same memory footprint. And that can be useful. That could be exactly what we want, but sometimes it's not. We want to copy the list, but actually keep an actual copy of it. In other words, if you create a photocopy of something and then you write notes on the photocopy, that doesn't change the original, but in this case it would. It's like they're a sort of a digital copy where you sort of change the one and then it changes both. Okay, so if I had to now say so we go my list dot append, and then we just append something, like I append a 3 to the end of it, right? Now when I print my list, we have our 3 at the end, but what if I say x? Well, x now has a 3 at the end as well, because these two have now been linked. So x equals my list. Well, now they share a memory footprint. Anything I do to the one alters the other. If I say del x and then give it maybe index 8, right? And now when I print x, right, it's missing an index. Okay, so it's missing this 6, but my list will also be missing that 6. Cool. So sometimes this is what we want, but if we want to actually create a proper copy, and then when we alter one, it does not alter the other. If you have the newer version of Python, then there is an actual function called copy, right, that you can run on lists. Okay, so if you are using Python 3, then you can use the copy function. But in both Python 2.7, which is what we're using here, and Python 3, if you want to create a copy, you can just use a slice that goes from beginning to end, right? Because what that's doing is essentially saying, so let me use y as my new variable for this. So I say y equals my list, but then I give it a slice like this, right? If I print my list and I print y, they look identical. But really what the slice has done is it's iterated through this list, and it's gone for each item, it appends that item to this new list. And just because it has done it to every single item, now these two lists look identical. But if I type id my list and id y, you're going to see that they will have different IDs. Okay, and if I now say, well, let's just delete y5. Okay, now if I print my list and I print y, you'll see that they now have a different length of items, right? This one has a 4 that this one is now missing. Okay, that's because it was index number 5. I've removed it from y, but not from my list. Okay, so now these are actual separate copies. Okay, so that's working with tuples and lists, and this is kind of the basics of working with arrays. When we get to sets and dictionaries in the next lesson, you'll see there are a few additional steps to it, but a lot of these same principles are going to apply. All right. So I hope this makes sense and that it wasn't too complicated for you. But if it is, please, please, please come back, return to these episodes, listen to it again and again, because the sooner you can understand this, the more powerful your coding skills are going to become. All right. Thank you very much, and I'll see you in the next lesson.